I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have
All right, here we are back on the Zenith 10H20Z chassis. I've disconnected the audio output transformer and labeled the leads that they used, and we'll look into that in a little bit. Right now, I'm going to look at the power transformer and go over what's in here and what I've found out thus far, and we can discuss it. Before we start, though, a couple of clarifications. One is, last time I was talking about how resistors typically fail by opening, which is generally true. Caps can short, resistors generally open. But Larry pointed out that these can domes, this is basically a wire-wound resistor wrapped with a steel can riveted to the side of the chassis to dissipate heat. And Larry pointed out that when these fail, they often will fail with a short. So the event that might have damaged burn out both transformers rather, and did who else knows what, might have been this can dome failing. So that's a very, very distinct possibility. The second thing to clarify is I made a statement about the 6v6 tubes and how well, let's take a look at the schematic. You might recall that what I was concerned about was the 315 volts plate voltage on both of the 6v6s, because if you look at the spec sheet for 6v6, that's right at the top of the plate voltage range. In other words, you're driving that tube as hard as you can, which is true. It's a higher voltage than it probably should be for longevity's sake. This is the Tungsol 6v6 spec sheet, and I was looking at we have a new addition to our household, a little kitty who's found his way. Molly has found her way onto my desktop and likes to play with a mouse while I'm playing with a mouse. Anyway, plate voltage right here, 315 volts, as high as it could be, highest operating voltage that you should run. What I failed to notice was this, highest plate voltage you should run in a single tube class A1 amplifier. And what we have here is, let me find this, a class AB amplifier with two output tubes. Now, what push-pull means is that the tubes share the work of generating the audio input for the audio transformer. So they're both sharing their work. They don't work as hard. It's more efficient this way, less work for the tube. However, and this warrants further looking for me, the highest voltage they have down for plate voltage in a push-pull situation, like we have with this Zenith, is 285 volts right there. And if you look at the schematic, they're calling for 315. So they have the plate voltage way high in the output tubes. When we get to that point, I will certainly measure plate current to make sure that we're not. There should be. This says 13.5 is the max. It should be around 12. So that's something to look at in the future. And by the way, if you want to know anything there is to know about push-pull or single-ended output circuits, check out Uncle Doug's YouTube channel. The guy is just so knowledgeable. And the techniques used in guitar amplifiers, which is what he talks about, are exactly the same as those used in radios. So some minor changes, but overall exactly the same. And he's really the go-to guy. So check him out. Okay, on with what we were going to talk about. I said I would calculate what kind of current requirements were necessary for this 10H20Z chassis, and this is what I've come up with. There are 3 voltages used in the system: 5 volts for one tube, and that's the 5Y3 heater. The 6.3 volt heater circuit provides voltage for all the rest of the tubes, and then the B plus voltage takes a little bit as well. But the big hogs are the filaments for all the tubes, of course. So here's what I came up with based on the specs from the tube manufacturers. The 5Y3 needs 2 amps from the 5 volt system. It needs, the remaining tubes need milliamps from the 6.3 volt system, but that adds up to about 3.15 amps total. Then the B plus plate current, if you look at all the specs, stop that. Cat's trying to eat my microphone. The B plus plate voltages, plate currents, all add up to 0.229 amps, but that's 72 watts. So here's 72, here's another 20, 92, and another 10 is 102. So this is about, a little over 100 watts altogether. So now we have to look at what's in the chassis right now. And what's in the chassis is indeed a Zenith transformer. It's a 951228, something like that. It's not the same transformer as was in the original, 1283, I guess. And the only information I can find on it is what it says right there, which is it's a 100-watt transformer. So, boy, I don't know. It worked for a while, apparently. It might be better than the original, but I don't know. And as Dawn at Restore Old Radios pointed out, Zenith transformers of the era don't have the best reputation at all. So no surprise that they got fried. And who knows, maybe it's the circuit design rather than the transformer. Don't know. I got to tell you that source information on these Zenith transformers is mighty hard to come by. I finally found in a 1953 magazine on radio television, I found a transformer substitution table, and apparently transformers were burning up and falling out of the sky back in those days because they had to publish this table of transformer replacements, of which, to be fair, Zenith was just one. But what the original radio had in it was this 951253 transformer right here, and that table from 1953 listed 3 possible replacements: a Chicago transformer PV120A, from Halderson a P9314, and from Triad an R40A. And that was the quickest one to find other information on. The R40A provides a plate voltage, center tap plate voltage of 440 volts on a side, with 300 milliamps. That's for the B plus, of course. And then it has a 5 volt 3 amp circuit and a 6.3 volt 8.5 amp circuit. So that would certainly be beefy enough. You'd have to do something about this too high voltage to drop it down. The Halderson and the Chicago both have virtually the same specs. 360, which is probably what the original transformer was supposed to be, the 1293 or 1253. what else was I going to say? Oh, 5 volts, 3 amps on both transformers. The Halderson provided 3.5 amps at 6.3 volts. And the Chicago provided 4.5 amps at 6.3 volts. So this gives me an idea, a rough idea of what the original Zenith, this 1253 here, should have provided. So I don't know whether the original provided this kind of performance or not. It should have. In fact, I would prefer that the DC milliamps for the B plus be a bit higher than in the last 2 transformers. But, you know, the one that's in there probably worked for a while and still may work. Don't have any idea of its performance at all. But we'll fire it up as we put this all back together and measure it and see what it is doing. So that's it for this one. Next time we'll do the audio transformer. See what that's up to. See ya. Take care. Be safe.